Okay, we're going to be carrying on with straight line graphs and linear equations. We're going to be extending some of the ideas, but it all uses the same knowledge. Okay, so let's take this linear equation. No powers in a linear equation, and the question, just as a bit of revision, find the gradient and y-intercept. Pause the video and work out the gradient and y-intercept of the equation. Okay, once you've done that, in order to find the gradient and y-intercept, we have to rearrange so that it is in the form y equals mx plus c. Okay? We'll start with the equation. We could take away 3 from both sides. We could then add 4x to both sides. And finally divide by 2. Now it is in the form y equals mx plus c. M is 2, which is the gradient, and the y-intercept is minus 3 over 2. Or minus 1.5. Okay. This would allow us to plot or sketch the graph. Okay. It crosses the y-axis at minus 1.5. It has a rise and run. Rise divided by run will be 2. We could extend these ideas, okay, and we could ask the question, what is the x-intercept? What is the x-intercept there? How could we find that out? Maybe pause the video and have a think about how you could find that out. So, in order to find that out, let's look at the y-intercept from a different perspective. We've looked at it from the perspective of the y equals mx plus c, where c is the y-intercept. Okay? But we could go back and remember that points on the line are generated by the equation. So the y-intercept happens, well, where does the y-intercept happen? The y-intercept happens at the point 0 something. It's 0 across, and we don't know what the something is. It happens on the y-axis. For this particular question, the y-intercept, the coordinate is 0 minus 1.5. But we definitely know that the x-coordinate is 0. So if we know that the x-coordinate is 0, we could substitute that into our linear equation. So we know that y is equal to 2x minus 1.5, but we know x is 0, so y equals 2 times by 0 minus 1.5. So when x is 0, y must be 1 minus 1.5. Okay? So the x-intercept then. Using that new knowledge, how could you find the x-intercept? Pause the video and see for yourself. Right, we know the x-intercept happens at something 0. It has no height, so it doesn't have any height, there's no rise, there's no y-coordinate, the y-coordinate is 0, and it happens somewhere along the x-axis. But we know y is 0, so we can put that into our equation. So use the equation. So y equals 2x minus 1.5. But y is 0. So that means that 0 is equal to 2x minus 1.5. So 2x is equal to 1.5. Which means that x is equal to 0.75. So that x-intercept there is the point 0.75, 0. So we're using the understanding that points on the line are generated by the equation. If we know one of the x or y values, we can use the equation to find out what the other coordinate is, the y or x value. Okay. We're going to look at this idea. So, finding the equation of the line given a gradient and a point it passes through. So this is a straight line with gradient 2, and it passes through the point 7, 4. Okay, we don't know the y-intercept, we just know a point on the line. So how do we do that? How do we do that? Maybe pause the video and think for yourself. So we could start by writing down y equals mx plus c and substituting in what we know. So what do we know? We know m, we're told that in the question, we know m is 2. Sorry, we know m is minus 2. Okay, we know m is minus 2, so we can write y equals minus 2x plus c. But we don't know what c is. So the question is, how do we find c? Well, we know that points on the line are generated by the equation. So we know that the point 7, 4 is a point on the line and it must be generated by the equation. So if we put 7 and 4 into the equation, it would make sense. We know the equation looks a bit like y equals minus 2x plus c, and we know that 7, 4 is generated by it. So yes, we can write this as y is 4, x is 7, so 4 is equal to minus 2 times 7 plus c. This comes from the coordinate. Okay. Simplifying, we have 4 is equal to minus 14 plus c. So c, therefore, must be 18. Hence, the equation is y is equal to minus 2x plus 18. Okay. I'm going to do the third page from your notes now that you were given in class, since we have only gone to 6 minutes. So solving simultaneous equations graphically. We know how to solve simultaneous equations using numbers. These are some simultaneous equations. So solving means finding the values of x and y that work. Okay, and if graphically just means, for now, it just means using graphs. So I could plot these equations. That orange line there is the line y equals 2x minus 3, gradient of 2, x-intercept minus 3. Okay, and that yellow line is the line y equals minus a quarter x plus 6, goes through the y-intercept 6 and has a negative gradient of minus a quarter. Okay. So, solving these simultaneous equations graphically, well, that's just where they cross. So when the x and y values are the same, are the place where they intersect. Okay? It's the point of intersection. Okay? This point is the point 4, 5. So when x is 4 and y is 5. You could check that from the traditional methods of solving simultaneously, using the substitution method. We know y is 2x minus 3, so we can replace it and say 2x minus 3 equals minus a quarter plus 6. I could multiply everything by 4 to solve this, giving me 8x minus 12 equals minus x plus 24. Simplifying would give me 9x minus 12 equals 24. Adding 12 to both sides, 9x is 36, leaving me with x is 4. I could then substitute in to find the y value, and this gives me y is equal to 5, as I expected. So algebraic and geometric solutions are identical. They'll give you the same answer.